finish off with basically a panel discussion, opening up to the audience. We've got, I think we had one question that we'll review. So just to introduce Ian, Ian Gilmore is one of our senior laboratory advisor at Datamine, specialising in gold and lithium laboratories. Ian has over 40 years of experience, 27 years of managing ALS metallurgical assay lab and 6 years of experience as the laboratory advising services. Okay, so one of the questions was interoperability. So, you know, what's your thoughts about interoperability between manual and automated processing?
I think
Up close to you.
Sorry?
Is up close yet?
Seems to be working. Yes. I think there's probably people who are better qualified than me to answer that question, but I'll give you my thoughts on it anyway. Interoperability is probably not something you would consider with having automated analyses and manual analyses, whether that be sample preparation or other things. At this point in time, I know Mohammed talked about having some of his smaller robots in amongst people, but I don't think that is something that would occur in this day and age, for the simple point of view that they're really incompatible. His systems are put into cages, they're kept away from humans, the humans put the samples in and basically a sample comes out the other end. So they're not compatible together. They're certainly compatible in a lab. You can certainly have robotics, you can have manual sample preparation, but I don't think the two interact very well together other than those limited uses where humans put the samples in. So I think that's really the only thoughts that I have on it, is that it's wouldn't be a common thing to occur, to have systems whereby people are operating in an environment where there's robots. I think it's pretty much not allowed in a lot of cases.
Yeah, and I think this next one kind of flows on from what you said. And can you does manual processes make more sense for a lab from either a commercial or operational perspective? Manual processes.
Look, it'll make more sense as long as they can make money out of that. For commercial labs, they're one of their big focuses is always money. So if they can make money with manual processing, they'll do that. If they need to implement robotics, they'll do that as well, if there's an advantage in it for them. It's really a commercial decision that they would make. I don't think it would particularly make sense one way or the other. If you've got good people, you end up with the same result most of the time anyway. And I think it's purely a commercial decision that they would make to operate on a manual system as opposed to automated systems. As I say, there are plenty of automated systems out there and those things work quite well, but there's also manual systems that work just as well. Yes, Rob. You want to?
I've got some interesting points on that. Having been looking at those sorts of questions with Intertech and obviously with Bureau Veritas, the key is that you have similar types of processes that you want to do. So sample weights need to be similar. Doesn't have to be the same, to make sure that the feed into the robotic system or automated system is easy to put in, and the outputs are similar. So you want to have batch type parameters. So for instance, if you look at, say, the BV system, they can process 1,000 samples a day on their robots. So they need to make sure that they've all got 1,000 samples of a similar size that are going to be fed into that machine every day. If they don't have that, there's no point having a robot because it doesn't make sense. It's similar to what you're saying from a point of view that can you make money from it? Is it profitable? the parameters are you need to actually feed these things enough samples to make it make sense. If you don't have enough of the similar type of sample, has to be the similar material, so it's gold samples going in or it's iron ore samples going in. If they're different commodities, forget it. It just doesn't work.
Yeah, that's correct. An example of that would be ALS Metallurgy in Balcatta. They have a robotic sample prep. Metallurgy is, the sample preparation is very common. It's knock everything down to 2 or 3 millimetres, do what you've got to do after that. And so they put in a system to do that. It never really worked and hasn't, as far as I know, it hasn't been used in years. It's simply because I guess the parameters, the inputs into the system were not discussed widely enough, and they do get, I mean, a metallurgical sample can be 5 tonnes or it can be 5 kilos. It really varies quite a bit, and that makes a big difference to the robot. And if you've got to crush 5 kilos, it's quicker for somebody to do that themselves than it is to load it into the bin and then have the robot crush it, because it'll take half an hour. So, yeah, it's a commercial decision based on what's going on, I guess, would be my answer to that.
Thanks, Ian. Thanks, Rob. Just a question in relation to, new instrumentation or new instrumentation methods that are around. Obviously, we've heard about photon assay in the industry. What's your experience with some, new instrumentation methods or instruments that are, that you think is going to be favourable in the mining industry?
Well, that covers a lot of bases.
Mm-hmm.
Photon assays, I have some opinions on. I get asked quite a bit about photon assays, and the issue with photon assays is I don't know what the system costs. It's generally sold to you as a lease. So I don't know what it will cost for you to put one in yourself. But if you do lease the system, it has a production of, let's say, 250 samples a day or something like that. If you want to expand that, you've got to buy another system. It's similar to what Rock Labs do with their sample prep systems. So you've got to keep buying these systems to improve it. If you go for fire assay, for example, the results are very similar. It's common knowledge with many staff, but they're quite familiar with fire assay. You can upgrade your fire assay. You can double production by adding another furnace, another muffle, and maybe you might need a fume cupboard or something like that. But it's a lot cheaper to do that than it is to buy a new photon assay machine. Not that there's anything wrong with them. They do produce good data. There's some question as to the data down the bottom end, I think. But certainly they produce reasonable data for what people need. So they're good systems. Other technology, well, I guess there's things like, 20 years ago, ICP-MS was just coming in, and it was really for super duper low detection limit stuff. That's all it was useful for. You couldn't do iron ores on it and stuff like that. Nowadays, they're coming out with things like aerobic dilution. So they actually bubble through in liquid going into the machine to dilute the signal. So you can do things like run majors on ICP-MS. So that sort of things is pretty amazing. I don't think there's been much in the way of innovation otherwise. Things like switch valves for ICP OES, they've been around for a while. They speed up analysis. You actually run a plug of solution that you're going to assay, and then behind that plug you have the wash. So at any given time you might be taking a reading, there's a wash coming up and there's another lot of solution coming up. So, you simultaneous machines, sorry, I took the microphone away, but simultaneous machines will assay a sample for 20 elements in 15, 20 seconds now with those sorts of arrangements. So there's lots of little things that are going on with instrumentation, but in terms of innovation, the last few years we've had really the photon assays. That's about it, I suppose.
What about, was it you that were talking about laser ablation?
Laser ablation is another one, but it hasn't really taken off.
Why do you think that is?
It's expensive to set up,
Hmm.
and it's regarded as a bit of a black box, I think. They've now got LIBS guns, laser induced. I forget what it stands for. Laser induced breakdown systems or something. You actually can use a thing like a handheld X-ray XRF gun, but it's a laser ablation system, and that'll take a shot of, I think it's like a very small amount of sample. But they do have bigger systems which are coming online now that can do large amounts of samples. They'll shoot over a 20 mil area, and you can get pretty good results from those. But hasn't really taken off yet. People are trying to push it, but haven't seen anything happen yet. I've spoken to, there's a lady in Perth, Melissa Narby, who's been pushing that, and I've spoken to her at length, but nothing really happening in that regard at the moment.
What about that? We've had some discussions around handheld XRFs and that sort of in-field analysis versus, XRF analysis in laboratories. What's your thoughts on that and the way it's going to change laboratory analysis in the future?
Well, I think one of the things that will happen over the next 50 years, if we're still all alive and here, is exploration will move to sites. So wherever they're drilling is where the exploration assays will be done. It might take a little bit of time to get where they're getting reliable assays, but I think that's what's going to happen. Exploration will disappear to some extent, maybe not gold so much, but disappear to some extent off the agenda of the commercial labs because it'll be done on site. Handheld X-rays are getting more and more reliable and more accurate and quite precise. At Amtech, about 5 years ago, we ran a pilot plant on a handheld XRF, and that was with 52% zinc, 52 to 55% zinc, 8% lead, and the results were comparable with wavelength dispersive XRF using glass beads. So those sorts of innovations are getting better and better and better. For example, we can shortly be able to do rare earths quite well using a handheld XRF. At the moment, I think most of them can do 1 or 2 analytes, that's about it. But they are getting better all the time. And then, of course, step above that, you've got the desktops, which are better again, but not so much portable. And then, of course, you've got wavelength dispersive on top of that, which is the bee's knees of XRF. So there are lots of innovations, I suppose, in terms of improvements to the current things that we have. They're little bits and pieces and little changes that are making a big difference. But I think eventually one of the biggest thing I can think of is that the exploration will eventually shift to being on site, done by people on site.
That's good. Thanks, Ian.
Rob again.
Oh, Rob, another question.
Cold block. Cold blocks, it's been around for a little while. It's basically an infrared system where you can heat up tubes with acids in them. The block itself, I guess, to some degree stays cold, but the sample gets superheated. It's very fast for things like acarija and that. But again, we're talking about expensive setups, and you're talking about multiple units if you want to do lots. If you had to do 240 a day, you might need 20 units or something like that. It's got its place, probably not at mine sites at the moment, but it may eventually come down to that. There are mine sites that are smaller acarija sites. They may be the first ones to innovate in that area. But yeah, it's got its place, just not at a big site.
Oh.
Yes, Dave.
Ed.
You need to prep on these XRFs that you see as being used routinely in exploration. Will you need to prep the sample, or are you really envisaging just a couple of chips of rock underneath it?
In theory, yes, you need to do the prep to homogenise more than anything else. But what's wrong with having a set of bags of samples and running the machine along and doing 10 shots at machines, if that gives you a satisfactory result? It may not, but people will try it, I'm sure, at some point in time. But even if you need to crush the samples, you can do that. You can take out a Boyd on the back of a truck with an RSD splitter on it and set up your XRF in they can come with a frame, and you have a lid over the top, and you just set them up there, put a bag of sample on the top, close the lid and press the button. So, yeah, it can be either way.
Just to comment on the fire assay and bismuth. It's a shame there's no one from BV here, because they've been doing a lot of work on it lately, and you touched also on laser ablation, and that's a hot spot for BV as well. And I've been doing some work alongside them in relation to getting the supply of bismuth and getting low gold levels and what have you. But what it looks like what's happening with the bismuth is that it's going to be much more than simply a gold assay. It's going to be multi-element, and they're looking at gold, silver, throw in a handful of other base metals as well, more than likely, and linking the fire assay through to laser ablation as well. So that's about as much as I know about it. It's still very much a work in process, and BV have, I guess, come out in the open about it, and they're advertising now that this process is available. And I think over the next 12 months, 24 months, you'll probably see that emerge as an entirely new field, well, a very old field revisited, I guess, as far as bismuth goes, but I think there'll be a lot more to it in the next 12 months or so.
Yes, I agree with that. The thing with bismuth is it's not lead. That's the big thing. So you're not having to, at this point in time, may have to in the future, but at this point in time, you're not having to monitor lead, and you're not having to monitor bismuth. So there is that innovation. The problem we have with bismuth is the buttons are very brittle. If you drop a button, it's going to smash like a glass. So you've lost an assay. So fire assay doesn't lend itself to that process very well as it stands now. So I think you'll see some changes to the way that is operated just to for that fact. But nothing wrong with it. It's a good system. We tried it, I think about 30 years ago at Amtech or something, and it worked quite well, except we did find out through experience that the buttons are not very strong, they're actually quite brittle. You've also got things like nickel sulfide collection as well for platinum group metals. Not too many platinum projects. Died, isn't it? Not too many platinum projects in Australia, but nickel sulfide's a pretty innovative one. It's a bit painful to run because you have to break up the button and dissolve some of it because it takes forever to dissolve, and then you've got to run an ICP-MS. So to a large extent, people tend to stick with lead collection for platinum group metals, at least some of them, and use that rather than go to nickel sulfide.
Oh. Artie.
Yeah. Hi, Ian. How you going? Just a general question here. QAQC. I'm going to touch on QAQC. So us in the lab, we would have the results, and then we always do QAQC with the Perth lab. So in this case, it's actually BV. So sometimes, obviously, the data supports each other with the QAQC, and then sometimes we got a difference between the data, my results, and then BV results. So what do you take on that? Which one's right? I'm right, or he's right?
How long's a piece of string? Yeah, look, it happens everywhere I go. People say, usually when I'm called out to a mine site, it's because there's somebody's had an issue with the assays from the assay lab. As we've seen today, a lot of the cases, it's not actually the assays that are a problem. It may well be the samples, how they've been taken and where they've come from and so on. So that's often the case. But if you get discrepancy between two results, the only answer is to get a third result. It's the easiest answer. You can justify your results. You're validating your results in your LIMS in CCLAS by saying these standards are supposed to be 10, I got 10, or I got 9.8, whatever. So I'm justified, but they've got a different answer. So you have to go to a third assay. It's otherwise known as an umpire assay, but it's very, very common in mine site labs. But you know, you hope that you can, when I go there, I hope I can find some sort of problem. I don't always find it. Sometimes I find it after I've been there and got home and worked it out. But you hope you can find some easy answer for what was going on. I was talking earlier about a mine site I went to in WA, not yours, by the way. It was, they had high tails and low mill feeds compared with check assays. Well, I went into the lab and the guy said, well, they've got carbon in their tails. So I went and saw them and they said, no, that's all fixed. We fixed all that. And then as I was about to leave, he showed me a sample with carbon in it. I still have the photo. And I went over and saw them and said, you haven't fixed it because here it is. Here's a picture of the carbon. So that's a case where, you know, they assumed, very common in this business, the assay lab was wrong. And in this case, the assay lab was probably absolutely correct for the sample as received. The sample as received was not representative of what they're trying to assay. So it's a very common thing in mine sites. I've been to some where people say the lab's wrong. They're using a PAL, pulverise and leach machine, which is a great big machine with 51 pots, I think it is, on it. Takes up to sort of 250, 500 grams of sample, has media inside to grind it. You add an assay tab and it gives you a cyanide soluble gold. And they say, you know, the results are unreliable. They're all over the place. And then you go and look at the system. The PAL works with a trigger gun that is timed to give them exactly 1 litre or 500 mils or whatever they're trying to do. So these guys are trying to do that, and the mill is turning off and on the water. The pressure's going up and down. The guy standing there is going, coming out at 100 miles an hour, then it's trickling, then it's coming out 100 miles an hour in the same pot. So there's lots of things that can go wrong that are not always the fault of the assay lab.
And just open question to the audience. Any people, you know, that are working in laboratories now that you've got, you know, problems or questions that perhaps Ian could to answer?
The other question I was going to ask you is, as a mine site lab, what's the pro and cons having a contractor like commercial lab to run an on-site lab?
Yeah, look, the commercial labs on mine sites is not a good look, I'm afraid. I know there's people here who might disagree, but I've seen it happen so many times. They go in, they quote low on the prices, and then they have a price that covers their leases for the period of time they're there, and then when they're finished, they flog it off to the mine site company. Sometimes they just keep operating. But what happens is they start out with 20 samples a day, and then it becomes 50, and then it becomes 100, and then it becomes 150. And then all of a sudden they're doing these very cheap prices for the assays and they're losing money. The client's losing turnaround because he's not getting his assays fast enough. And then there's this bun fight goes on between the commercial lab and the mine site because they want the commercial lab to put more people in, but the commercial lab knows they can put more people on, it's going to cost them money. They're going to lose money because they've gone in cheap for the prices. It just seems to be a common fault that they all do. They all go in cheap on the assays and the lease costs are covered in a monthly fee or something, and it never works out well. Having said that, if your lab is run by a commercial lab and it's the sample volume is fixed, then it works quite well. But remember that they're a commercial enterprise and they must make money. If they're not making money, they don't want to be there. So that's the biggest problem. And quite often they'll put, I've been to a gold lab where they had an XRF guy in charge of the gold lab, and he was reporting Aquaregia assays that were 10% low all the time, and he couldn't figure out why. But what they were doing, they'd reached a sulfide zone, they're adding a lot of nitric to oxidise the sulfide, they weren't burning off the nitric, so the gold wouldn't release on the chelate on the aliquot 336. So that it's stuck in the solution. Some of it's still stuck in the solution. So I got them to dilute the sample before extracting in DIBK, and it worked. But you know, this was because the guy was an XRF chemist. He probably ran an XRF very well, but wasn't aware of Aquaregia, the vagaries of Aquaregia assays.
Thanks, Artie. Perhaps any, as we spoke about AI, anyone would like to share how they're using AI in their lab or their businesses? I know we don't all have lab people here, but would you like to share with the audience how you're using AI?
All right, so we are using AI. I mean, because I'm working in the laboratory, and so we're using the AI inside the safety aspect of it. So not really in the actual laboratory process, like you know, obviously Datamine, and then they're gonna do it inside the production bit. But for me, we're doing the AI inside the safety aspect. So obviously, all risk assessment, everything that we do, we're going to look into it, have a risk assessment before we do our jobs. And so when we do our jobs, another AI thing that we got our system, we just talk to our phones instead of writing a take five. I don't know if you're familiar with the word five. So just talk, all right, cool, I'm going to do acid digest, and then these are the risks and the controls. And you just say it in there, like you just talk to yourself, like, I'm going to put in the furnace, or this is going to be hot, I'm going to use my gloves, I'm going to use tongs, you know, blah, blah, blah. You talk to it, and then give it about 5 minutes, and then the AI coach will come in. So the AI coach will come in, and then they will tell you, like, okay, so he said he's going to do this with this control, this, but he forgot this, and what about this, it will be good. You know what I mean? So that was the AI stuff that we got on site, which is actually really cool. And I can actually show you. I have it on my laptop, and then what it looks like. I got it on my phone, so like I'll show you what it looks like. AI coach is actually really cool. And but that's what we do now with the risk assessment in the safety side.
Oh, that's great. Thanks for sharing. I actually forgot to present this. I wanted to show you guys, because we have Datamine has all of the help files online. So, you know, for our customers right now, you can actually use ChatGPT. You don't need to, you know, reference the knowledge database. So I've got in here just normal ChatGPT. How do I create a scheme in Datamine CCLAS, right? I did this yesterday, so hopefully this works and doesn't give garbage. So it's talking about logging on to CCLAS, opening up schemes, adding a new scheme, defining your methods, linking the methods to samples, adding QCs and saving it. So it's you know, you can utilize that right now, right? So we've got a lot of documentation on that knowledge base, all the help files. So, you know, it's something probably, Rob, that, you know, in the future, you know, putting a large language model into the application, you know, is something potential. Would you want to just give your thoughts on possibilities?
Yeah, and I wonder if I can throw that up on screen.
Yeah, absolutely.
So I just want to reset, maybe do a little tiny reset of from the idea of that's it, yeah, of AI being just like ChatGPT and nothing more as such. So we're used to bringing up ChatGPT and then just feeding it English language, and it gives us an English language output. So I think we're all pretty familiar with that. As a programmer, that's a bit of a party trick. Where programs are all somewhat amused by the party trick of ChatGPT. It's been a bit of an in-joke in the programming world. But there's a lot more to ChatGPT, and there's a lot more to large language models. And what I'll point out in amongst here is that there are elements involved. I lost the screen over there. I think it might have popped the power off when that tipped over. What's back? Okay. So I'll just quickly point out, this is very impromptu, but at the heart of this thing, you've got a logic processor. So that's your whole AI system as such. If you like, that's ChatGPT or alternative. But at the heart of this, there's a logic processor. So the logic processor is more or less a reasonably pure logic processor. It's just been given a task to solve a logic puzzle. You've given it some clues, and it's got some information available to it, and it's just coming up with an answer. That's a standard computer programming problem. It's a fairly decent logic processor. It's fairly powerful, but we've seen the errors come out of these things. So what's interesting about LLM systems is this leading edge to the thing, where it does language processing. So as a human being coming into the system, you're feeding it English or Spanish or Japanese or pick your language. It has to decompose your perhaps correct, perhaps clumsy English language into something that its AI logic processing engine can make sense of. And then it goes and finds some information in its internal resources. It might use some personality and imagination to help compose an interesting answer as opposed to a very dull answer. And it also might retain some of that in a session history so that if you ask it sequential questions, it can come back with something relevant to what you've previously been asking. And it comes back out as from here as pure logic, but then it has to recompose that into the language of your choice at the start, which was originally, it was English if you're a human being. So what program finding really powerful about this now is not feeding it English, feeding it JSON or XML in a structured way, so that you eliminate this whole language processing error session. This is kind of like what we're talking about at sample processing before, that leading edge to the processing is one of the error-prone stages. So kill that all off, feed it structured data, and tell it, I want responses in this structure. And so it's not trying to recompose English, it's recomposing a data form that you want back. Now you can do this from an English prompt, but programmers are starting to use code to hit these APIs with structured XML or JSON queries, getting the information in a clean data format compliant to what their code wants. Now, on top of that, you can go outside of what's provided in the large language model system and reach out to external knowledge sources, and also provide it pointers to specific tools to do external processing. And this might include your old scientific models written in Fortran and whatnot, and various other resources that are proprietary, and you don't have that available in the general commercial model. So this is sort of called context engineering, part of this here, where you're reaching out to external knowledge sources. So again, back to what a programmer's doing with this sort of stuff now, is they're realizing that well, we've got to say a complex problem like looking at the history of samples coming through a plant and saying, well, we want to optimize the processing of the next couple of weeks of samples that have been queued up into the system. We want to process that into the most cost efficient or the most cost efficient or the most time efficient or profit efficient. You might feed it different parameters for what you want to do, and then have it spit out that sequence of processing. So that's something a human being could do reasonably well with some spreadsheets and a couple of 100 hours of time. But you can just flick all this to an AI engine and say, just figure this out for me, please. But by using proprietary tools and feeding it proprietary context, you can really hone this down to specifically what you yourself want in your context much better. There's a few strange traps and things in this where you've got the ability to set, say, the temperature on the personality aspect of this. So something not everyone's aware of, you can actually tell this thing to be less imaginative. And you really do want to do that in a science or engineering context. You want to tell it to bring the temperature right down. High temperature is very imaginative, typically 0 to 1, where 1 is very imaginative, and 0 is apply no imagination at all, please. And that's variously set in different engines. And there's a retention problem here with the session history, where at least in some examples I've seen in asking it sequence of questions, it will start to forget things you asked 4 questions ago or 5 questions ago, and you have to reassert, no, I want you to maintain the context that I fed before. So if you take these things into account, getting back to the original question, how is this being used in LIMS and so forth? But the example I gave about using history of samples coming through and how you can predict, how you can propose sequences for the future, that's a good example. But why I'm doing this is I think if you get into your mind what's involved in an AI engine, that it's just a logic processing engine, basically. And it can take various languages, either colloquial or very proprietary and very structured, and tap into public or private internal resources, or again, public or private external resources. You can run entire LLM models privately. You don't have to use public ones. There are open source privately deployable LLM models that you can install and run, where all of this is internal, so you don't have to worry about leakage of information out of the system. So taking that into account, you can usually look at your own context that you're in and think about, okay, how do I get LLMs to work for me? And think, well, it's just a smart assistant, but you're going to get more out of it if you give it the context clearly, feed it context, so tell it what context resources it can reach to externally, or feed it context from the prompt, potentially give it tools to reach to, and make clear about some of these things, about the temperature and retention that you're interested in for your particular questions. That might help you yourselves to think about how can LLMs apply to me in my space. It might not. You might still be there going like, I'm still baffled. I'm still a bit sort of dizzy with the whole LLM thing. I'm going to throw a question over to Scott Carpenter, because Scott Carpenter's just sitting there thinking, he's our AI evangelist in Datamine, and he's probably sitting there going, Rob, clap, 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 or Rob, tut, tut, tut. Go, Scott.
I'm shocked, and I'm glad I'm sitting down, but you're on the right track, Rob. No, that's...
He says this because I am a fairly deep AI skeptic, having been in programming for now, I'll call it, it's 1980. That's when I first wrote code. So that's 45 years of programming history. And AI came along and I looked and I thought, yeah, here we go, another one. But I think this is just another excellent programming tool.
Oh, definitely. And AI, of course, I mean, we seem to be driven by the James Cameron's 1984 sort of epic Terminator, of course, the whole dystopian future. But as far as technology, it started off quite optimistic. If you think of the 1950s, Jetsons, flying cars, food in pill form, and then something flipped. Probably the Cold War contributed to that with our Oppenheimer moment. But ultimately for me, where we're faced with AI and applications in business, there are two things going on. First is we're in a hype bubble, of course. And the second is we seem to have come to an expectation that AI will be perfect, it'll solve every issue. And then when it's not 100%, we cry.
we say, well, that's useless. I'll go back to what I'm doing before. And so I have to ask, what technology or innovation that's ever come out in history has been perfect in the first version, the first release? If we look at history, we iterate, and yet there's this thing with AI, it's like a gotcha moment. Oh, I've made a mistake there, can't use it, it's terrible, walk away. I see nodding here. My other AI evangelist. And the other aspect is what impact is it going to have? And there's really two impacts that we see of. Is it going to be substitutionary? And like a big fair concern, is it going to take jobs away? Or is it going to be complementary? A bit from column A to column B. And you see a few, Klarna is a mortgage broker in the US that got very excited and got rid of a lot of people. We'll just replace them with AI. And then tail between the legs hired a whole bunch of people back because in shocking news, people like interacting with other people. And so anyone here who's gone through the voice system, are you rushing to hit the operator key? No, I don't want the options. I want to talk to a human to get things done. And so it's those, I mean, for me, those two aspects. What's our expectation of AI? Do we think it has to be perfect? And I think for me, a real revelation moment was listening to a podcast recently, and it seemed that with AI, we have an expectation that it would be solving our mistakes. It'll be fixing our problems. Again, it's that high-level expectation. Or is it actually that we're fixing AI's problems? The human remains in the driver's seat. It gets to the 90%, the 95%, and we deal with the 5%. Whereas previously we thought, oh, it's going to get to 100% and then some. And also, how is it going to get applied? That substitutionary application or complementary? Now, there's certainly a lot of applications where it's substituting, particularly something that is repeatable. But again, with AI, just remember the name. The A stands for artificial. You know, we hear of reasoning models come out and go, oh wow, it's finally here yet. But at the core of it, you have statistical models based off a corpus of knowledge. We start to go into the ethical concerns with large companies scraping other IP to train their models. That's a topic for when we're having a drink. And again, it's a whole bunch of very, very clever algorithms that are getting smarter each day. But again, it comes back to, and it's been the focus with this symposium here, is how is it helping us serve our customers better, safer? How is it helping us, I think, as people grow as well? So certainly can't. No, it didn't touch the ground. So, or it can bounce once, and you've got to catch it with one hand. But back to Rob's question here. I mean, when we hear AI these days, we're thinking the large language models, your Copilot, ChatGPT, Gemini, Claude. That's the AI, and that makes all these old school machine learning researchers, they just cry at that point. They think, hey, hold on, we've been doing this for decades. And so there are a lot of machine learning applications that are mainstream. Now, computer vision is one example. If you go to a supermarket, the self-serve, there's a camera watching you. To help you, of course. Also make sure you don't steal things. And you go through a tollway, camera's reading your license plate. That's AI, if you will, mainstream. As to the use cases for these large language models, there's over, OpenAI, I've said we've got more than 700 million active monthly users and growing. Microsoft is working incredibly hard trying to catch up there. Who will win the race? I don't know. But again, it comes down to how is it helping us? How's it helping us grow? And sort of any sort of effort to say, well, you know, I'm going to throw out the human and just blindly trust the AI is quite optimistic. And it needs to be a very, very careful consideration because it's artificial, remember? It doesn't have intuition. It can certainly help. There have been claims that it'll take jobs. One is with, there was a claim of about 5-10 years ago, radiographers, right? That AI would replace
radiographers because it can do the computer vision here. This is the mainstream tech. Except what happened is it opened up the addressable market for radiography, right? It made it more accessible. Prior to that, it was more expensive, okay? And so now, if anyone here is playing social sports and haven't stretched enough and done the injury, I see some smiling down there. One, yep, same here. It's quite common for you to be referred to get an MRI these days. That's almost standard procedure. Prior to the technology that came in, it was a lot more expensive. So for your sports injury, is it touch footy, soccer? Oh, that's a great one. Ankle, knee, ankle, yep. To be able to go get an MRI now, with thanks to technology, it's actually providing more employment opportunities and helping to win the premiership. No, not this year, next year. So yeah, we don't know the future. We can look to the past look at other technology examples and how things have changed. But I think keeping grounded in the problems that we're trying to solve, keeping people central in all of that. So as far as for me, and being quite conscious of are we looking at a complementary, or a substitutionary use case, and if it's going to be substitutionary, which we've seen in our presentations with robots. And that is substitutionary, but notice there's still a human monitoring that activity. So keeping that in mind, keeping our feet on the ground, and I suppose taking advantage of the learnings at least with the technology that's coming out. So Dion is someone who's been embracing tech, looking for the opportunities there, but it's still very much the human in the driving seat. And I think for the moment and from time on, that's a key principle.
I could be wrong, of course, but I find AI is basically a huge advantage point of view that it speeds up access to information that's available in the public sector. If it's not available in the public sector, it's probably not available on AI. But it's a fantastic thing, similar to what our friend did on his mine site for his safety. It's an available thing. So it can provide that information quick to anyone who has access to the AI, which really, that's a needed thing and it's a valuable thing. It's not going to tell you something new that hasn't existed yet, the knowledge. It's not the exploration scientist, it's not going to do that. But it can put all the pieces in front of you so that you can join the dots to make that leap. So there's still somebody that needs to do the leap, but it can make the access to it. And a good example, Dion, was you and I doing my presentation. We didn't have time to go and ask for permission to do photos in people's laboratories and get signed permission and all the rest of it. We used AI and it was amazing. We got realistic looking people. They don't exist, by the way. None of my presentations, none of those people exist. They are AI, but we got the message across quite quickly and simply. So it presented the story.
I wonder if I can inject two stories of AI usage. One in our own context, so integrating limbs to instruments. So there's many different kinds of instruments. We're only dealing with one limbs, but there's also many different kinds of limbs. So if you go into, there's a many relationship between all those different systems to try and work out, and they're all different, so they all have different interfaces and protocols between them. So we were presented with some, please integrate CCLAS with a particular instrument, and our developer took it as an AI exercise, and there was a manual for how to program to that interface for that instrument. Sorry?
That was Exaquantum.
Exaquantum. So,
yeah. So that plan information management system.
Yep.
That plan information management system.
Okay. Do you want to? So So Dion certainly knows more details. You can drill him about more details. But there was basically a interface implementation manual that was provided with XQuantum, and the programmer just grabbed the PDF of that and used it as this external knowledge source with the prompt and said, here's the PDF, point to that, and tell me I want to connect to and extract this sort of information from the system, and tell me how to do that in VB. So he guided it in giving it an answer that wasn't in English. He said, no, I actually want VB script, kick back out, not English. So he was guiding it in relation to the language output. He was guiding it in relation to the external knowledge source. It was any external tools provided. And it used some internal knowledge, which was Visual Basic programming up to a year and a half ago, according to whatever information source had been used to build the LLM. And it spat out the thing. Now he had to go through a number of cycles where he said, well, yeah, okay, I tried that, but I got this error. And it came back and said, oh, okay, well, sorry, I got that wrong. And it came back again. But he got that done in about half a day, I think. And it was conceivable that might have taken a number of weeks to do otherwise.
That would have been weeks worth. So I think that was also we shared that across Constellation Software, didn't we, Scott? Yeah. It's a case study. Do you want to comment on that?
So that's a good example of context engineering, of providing the context to the model to use, the PDF that's being fed in.
I want to comment on it, but I'm looking over at our students here, and surely, I mean, if I can stereotype you all, which is terrible, I mean, other people stereotype, I don't. You must be using AI. Of course, so there we go. Love to hear, don't want to put anyone on the spot, but I've sort of done that already. Is there any, I suppose, would you be comfortable sharing how you're using AI, how it's helpful, pitfalls, learnings? Oh, yes.
Well, at the moment, for organic coordination chemistry, we have to make a poster on a primary paper. So we have to look for research papers on coordination and moths and stuff. And so how we're using it is, instead of reading through all the paper, you would just put the paper into the AI model, summarize it, what are the aim, what's the method, what are the results, and basically help me break down complex topics and just summarize the key points. And then, yeah, so that's the main use at the moment. Finding articles, yeah. I just found a new AI model. I think it's called Anara, and that's used for like research that researchers use, and you can put papers into there. And so, yeah, there's plenty of models. Mainly do use ChatGPT, but I think there's other ones with like specific uses. So that's, yeah, well, that's me.
Great, thanks for sharing.
So I'll just use what she's just said there and say that Anara, that's a tool. So you pointed it as a tool, and the context that you pointed it to was the research papers, and you said, well, look at these research papers now, put them into Anara, and etc. So there's a couple of different things there that are falling into a fairly common pattern that people are talking about in the industry. The other example I just wanted to recite quickly was a cautionary tale for professionals using AI. This temperature setting here is something to really become intimately familiar with AI engines. The example I have to recite is I did write a paper which was about 130 pages long on a topic some 15 years ago. Not published, or published, but only inside the Queensland government. Visible on the internet. And I thought, the AI engine, ChatGPT, might know where that paper is. I'll ask it a question. I said, please tell me what you know about this particular location managed by the Queensland National Parks, it was, in relation to a report done by Robert Manthe. And it spat me back a great big, oh yes, here's the summary. Robert Manthe provided a report on this particular national park, etc., 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 etc. His recommendations were to manage it in, I won't say what, but to manage it in this way. And it also included information about Aboriginal affairs. And I looked at that answer and I said, well, no. One, that's not what I recommended. Two, I didn't partake of any commentary about Aboriginal affairs. I thought, well, hang on, I hadn't set the temperature on this thing. It had just imaginatively provided that. I was quite concerned about that being what the public would find out if they asked a question of the engine about that report that I'd made. I then thought, well, hang on. I asked it, okay, same question, but with another person's name, Dick Johnson. Tell me about the report that Dick Johnson provided on this particular national park. And it came up with the exact same answer. And so it was prepared to, with the temperature at the default setting, ChatGPT was prepared to completely fabricate the existence of a report on a thing that I knew there was a report on, and it got it completely wrong when it recited me, but it also got completely wrong and fabricated an answer about a completely fictitious person writing a report on that as well. So as a professional, you need to be really aware, excruciatingly aware, that ChatGPT, in its default settings, is imaginative. And if it doesn't have an answer, it will make up one. It will just make up one. That's on temperature, default temperature. So the temperature 0 is use no imagination. Temperature 1 is use a lot. Temperature, if you go above 1, I haven't tried it myself, but I was told recently that if you go above 1, if you set it at 1.6, it just makes up extraordinary fantasies about rabbits jumping on the moon and everything else. When you ask a question about anything, it just says extraordinary things.
Thanks, Rob. Yeah, so I think it's just a note to to validate, just like any source. Prior to using AI, if you found something on the internet, you had to validate it. I think that's the same thing. Did you have a comment in?
Yeah, I had a sort of a comment. I think, I can't remember who it was who said this, but we tend to overestimate the value of innovation and underestimate the long-term effects. And I think that's pretty appropriate for all innovation, really.
Thanks, Ian. Well, we're at time now, so thanks everybody for participating.